Hello everyone, this video is going to go through the modeling of a 10-cell burn building in CFAST, and it's going to be comprised of three separate parts. The first part is going to cover setting up the model geometry, and so this is what this image is. We're going to assume a room height of 2.9 meters, and then we're going to build out the rooms as shown here. The second video is going to go through setting up some disappearing vents that are going to disappear at different times throughout the simulation, and the third video is going to go through setting up compartment fires in different compartments, different types of fires in different compartments. So I do want to go through, we do have a disclaimer here. The information presented is for educational purposes only. It is believed to be accurate and reliable, but no warranty is expressed or implied. I'm not going to read the whole thing. It'll be in the description below. But normally the user is obliged to obtain professional guidance for any decision affecting the life, affecting the safety of people or property, and this information shouldn't be used solely to make those kinds of decisions. So we want to get started. So we're going to use this diagram to build our simulation. And to get started, we're going to open CFAST. We can either look for CFAST in the programs of our computer, or we can, if we're running it from a flash drive or something like that, we can double click on the CEdit application. And I'm going to make this full screen so all the buttons show up. And then I'm going to create a new file. I'm going to save it. I created a separate folder on my desktop. If you watched the introduction video posted earlier, we went through this user's guide example and the installation of CFAST and some various things that are helpful to know about the program. So we're going to call this burn building version 01, and so we are as far as I'm aware, the old versions of CFAST, you didn't want to use any spaces, so I haven't checked the latest version. This is version 7.2.4, but I tend to use underscores instead of spaces, and then I do versions because as we go through the simulation, we're going to save versions as we go through, so that if one file becomes corrupted, we can drop back to the last one that we had. So if we look, my screen really isn't big enough to show you this picture at the same time as I'm working in the CFAST GUI, the graphical user interface, so I'm going to refer back to it, but I have a printout that I'm going to work off of. So compartment 1, and we want to name these. So I'm going to name it 1A so that matches the description in I'm going to flip back and forth a little bit. So we have 1A, compartment 1A here, and so if this is our origin, this bottom corner here, our 1A compartment is going to have a location of 0, 0, 0. And then these in our diagram, these dotted rectangles represent windows that are 1 meter by 1 meter square. Doors represented by these little figures here are 2.2 meters tall and 1 meter wide. The sill is at 0 meters. The vent offset is at 0.1 meters on the left side, assuming we're on the left side. Windows are 1 meter on a side, the soffit's 1 meter, the sill is 1 meter, and the soffit is 2 meters. The vent offset is 1.5 meters, and we're going to show you how all that works. So the vent offset for the doors, we have to play with that a little bit to get them in the right locations. So we figure that out as we go along. Alright, so compartment A1, its width, if we look in the x-axis, is 4.8768 meters. The depth, that would be the y dimension, is 4.2696. and the height is 2.9, like we said. Position 0, 0, 0. Right now we have the thermal conductivity off, so we're going to be treating all of the walls as inert. If we wanted to, I showed this in the last video, but if we wanted to get default information, we could click from file, and then we go to the location where these stores are, the files are stored, and then we're going to click all files, and we are going to go down and select this thermal file, and then if we select all and click OK, then we have a lot of different materials that we can choose from, and then we go to our compartment. We could set our materials to be one of these choices. I'm going to leave it off for the purposes of this example. Just to be aware, if you are using these parameters, these are sort of input parameters. I haven't seen literature that shows these are necessarily accurate. If it's in the user's guide, then that's good. I haven't seen it, but I haven't looked that hard. But if you're going to use these numbers for real life safety analysis, you want to make sure that they're legitimate, such that if you went to court, you could justify the uses of those numbers. Alright, so if we have compartment A1, and now we want to add the vents to compartment A1, and so we're going to click add, and this is going to go from compartment A1 to the outside, and we'll keep our sort of nomenclature consistent. We'll do doors first and then windows, starting from the horizontal and then going to the y-axis, x-axis, then going to the y-axis. So for our doors, our sill is at 0, our soffit's at 2.2, the width is 1 meter, and the vent offset, and this door is on the right side, so I'm going to set it to 1.1 and see how that goes, and it's going to be on the front face. I believe that'll put it on the lower x-axis. So I'm going to click save, and then just to look at the geometry, I'm going to click this geometry button, and I should be able to view. So I have my box here. Now if this is the x, the 0, 0 axis point, I want this door a little bit farther across. So I'm going to test. If I set this to 0.1, click geometry, right, I'm going to click save, then click geometry, then click view. So it shifted the other direction. So if I want it 0.1 from this edge, I take the width of the room and subtract 1.1. So this room is 4.8768. So the vent offset is going to be 3.7768. So if I save, click geometry and view, that gets my door over where it shows on the figure. And that figure I'm talking about is the doors here. Alright, so then I'm going to add the window on the x-axis, and unfortunately these aren't, the vents aren't named, so we want to have some sort of process where we can identify which vents are which. Okay, so this is going to be from A1 to the outside. The sill is going to be at 1 meter. The soffit is going to be at 2 meters, the width is going to be 1 meter, and the vent offset is going to be 1.5. That's what our description said. It's going to be the front face as well. We'll add our second one, second window, same deal. We could potentially duplicate, but I'll let you use your best judgment. I tend to forget some parameter and it's copied over from the left, so we should be setting this to the left. So I have no errors, so I can save, click geometry and view. Basically clicking geometry instead of run will generate the geometry, but it won't run through the analysis, so it saves a little bit of time, though CFAST tends to run pretty fast. So it looks like we're looking well. We have the door, the 2 windows. So then we'll go to compartment 2A. So we'll add a compartment. We'll name it compartment 2A. Now our width for this compartment is the same as the last one, 4.8768. Our height is going to be the same, 4.2969. Our height is going to be 2.9. Now the position is what's gonna change here, right? Instead of being located at 0, 0, 0, now our location on the y-axis is 4.8768. And we can save, click geometry, click view, and we can see now we have 2 compartments and they are side by side. So in the model, this wall has no thickness in terms of the spacing. So check your user's manual for how, let's say, the thermal conductivity of a wall is going to behave and how you accurately represent. So let's say we were going to make it acoustic tile, we would have a thickness given there. So make sure you're using the correct thickness if you are going to use that function. Okay, so then we're going to add the wall vents. So this room has a door and a window, so we're going to add the door first. So it's going to go from compartment 2A to the outside. Sill is at 0, soffit is at 2.2. Width is 1, and then the offset is going to be the same, the width minus 1.1, so that should still be 3.7768. Faces on the front, and I should be able to add another one, and this will be the window. It's going to go from 2A to the outside. Soffit will be at 1. No, sill will be at 1. Soffit will be at 2. The width is going to be a 1. The offset is going to be 1.5. I should be able to save. Click geometry and click view. And now I have my 2 compartments. So we go on to compartment 3A. Our width. So here's our diagram. We did these first 2. If we look at our width here, now we have a width of 3.66 instead of the 4.8768. And we have a door, but it's on the left-hand side of the room, and then a window on the right side. so our width is 3.66. Our depth is still 4.2696. The height is going to be 2.9. And then our position is, if we look at our diagram, our position is all the way 9.7536. It's going to be in the X direction. And then we'll go to our wall vents. We'll add the door. So this is going to be from 3A to the outside. Sill is at 0, soffit is at 2.2. Width is 1, and now since it's on the left, our offset should be 0.1. Still on the front, and then we can add our window. This is going to be from 3A to the outside. Sill is at 1, soffit's at 2, width is 1, and then our offset is going to be 1.1 plus, if we set it to 1.5 like we had before, I think it's going to be a little, it's not going to be far enough across. So, but let's check. So if we look at our diagram, it looks like the window should be a little bit farther across, and these are sort of estimates. We don't have specific window location measurements, but since this is a two-zone model, you might check and see how much the location of this particularly affects that zone. Could potentially, I haven't checked too in depth into if the way the fire plume is coated, if the location of the horizontal location of the vents affects the upper layer flow at all or not. Since it's a two-zone model, I would like to say that it doesn't, but potentially it could have been coated in to where it has an effect. So maybe double check on that if you're curious. All right, so we've done 3A, we're going to 4A. Okay, so we're going to add, this is going to be 4A. We have a width of 4.8744. We have a depth of 5.4864. We have a height of 2.9. Now our horizontal position is all the way over an hour at 13.4136 meters. We're still at 0 on the Y and 0 on the Z. So we might take a look and make sure we put that in the right location. So here we go. So now if we look at our diagram, this 4A has a slightly different configuration. And now so we have 2 doors and 2 windows in this room. Oops, I don't want to close that. I just want to minimize it. So we're going to go wall vents. We're going to go add. We're going to go from 4A to the outside. Our sill 0, soffit at 1, or soffit at 2.2. The width is going to be 1. This is a bit of a skinny door. The vent offset, we're on the left side, so it's going to be 0.1. Still the front face. We can add our first window, 4A to the outside. Cell is 1, soffit is 2, width is 1, offset. We're going to do similar to the last one, we'll do 1.9. And then we'll add the right-hand side window. So that's going to be from 4A to the outside. Cell is 1, cell is 2, width is 1, and the vent offset, we'll set it to 1.5. And this should be the right face. So let's take a look at our geometry. This looks about right. Now we do have one more vent back here into this 4B compartment, but we'll wait on that since that compartment hasn't been made yet. And what I'm going to do is save. So we just saved this. I'm going to go File, Save As. I'm going to save this to version 2. So we have this first row made. So if anything goes wrong, if somehow we corrupt this second row as we go along, we will have this first row made and ready to be worked on again. This newer version of CFAST doesn't seem to have as many problems with sort of the files becoming corrupt, but the older versions I had issues with. A variety of my students had issues with it, so I recommend saving often and saving different versions at regular intervals. So we're gonna go to 1B. The width is going to be 3.66. The height, or the depth, say, is 4.8768. Height is going to be 2.9. And now the X position for this one is still 0, but now we're shifting into the Y position. We want it to be 4.292696 in the Y position, so I can save geometry and view just to take a look. Looks like smoke view is starting to act up. So let me look. Do I have my burn building version 1. Here's my burn building version 1 SMV file. Now here's my I don't see my burn building version 2 here. Where did it go? Okay, so this went into the program files, and on my computer, when I have a file being saved in the program files folder, it won't run. So I forgot that was go to my desktop, go to the CFAST folder on the desktop. If other students have reported that they haven't been able to run programs when they're saved in the default installation location, so some people move it into my documents. I tend to move it into the desktop just because a lot of times if you're a Mac user, you may have trouble. Well, CFAST isn't compiled for Mac directly from NIST, so we can run CFAST from a flash drive on, let's say, a library computer or a computer lab computer where we don't have administrative rights, we can still run the program. If we copy the installation files from one Windows PC onto the flash drive and then go from there. So that's worked out for Mac users. There, I mentioned it in the introductory video I made earlier. There is instructions on recompiling CFAST on a website created by Dr. Overholt if you use your favorite search engine to try to find it. So if you want to go that route, more power to you. I know he likes Macs a lot. So it is an option, is what I was trying to say. Okay, so we have our cell 1B here, looks to be in the right place. If you see, you'll typically be able to see if it's offset here, if the boxes don't match up to what you're trying to create, you'll be able to see it in the window, in the viewing window. So we're going to create the window, and then we'll have to create the door after we go to compartment, after we create the 1BC compartment. So let's go to Windows, or go to Vents. We're going to select 1B. We're going to go to the outside. Cells 1, cell is 2, width is 1. We're going to make this 1.5, and then we're going to set it to the rear. Should be able to save geometry view, and there's my window. So I go to compartments. I'm going to go add. We're going to name this one 1B-C. This is the idea. It has a nomenclature C because we're going to set these long, skinny rooms, sort of their corridors. Really, they were hallways. So the idea is they're hallways. So we can set their flow characteristics to be that of a corridor. So we're going to do that. So the width for this one is 1.2168. The depth is 4.8768. The height is 2.9. The Y position, so the X position for this one is 3.66. The Y position is 4.292696. So I don't have any errors, so I'm gonna save geometry and view, and so I can see that compartment is in the right spot. I do this sort of mental check to look for errors because I had problems with the older versions of CFAST where if you clicked run when there was an error, it would somehow corrupt the file and it wouldn't be usable anymore. We didn't figure out why that was, but the newer versions don't seem to have that problem. But I'm still cautious. So we'll go to vents, wall vents. We're going to add the door from 1B to 1BC. We have 2.2. The width is going to be 1, and then the offset, we're going to set the offset as 0.1. I think this will get it right. It'll be on the left side. I'm not sure why it updates that when you change the face. That's okay. So for this one, it's put this in the 1B door, or the 1B room. And my understanding, if I switch this, it's still in the 1B room, and we haven't figured out, I haven't figured out why that happens. Initially we thought, the first one you identify is going to be where the door is located, but for whatever reason that doesn't seem to be the case. So, but we can switch this to the right side, this back to 0.1, and we will see there's our door in our correct spot. All right, so then we need we need this door to the outside. So we're gonna go from 1BC to the outside. This should be the rear face, 0.1 offset. So there's our door. Okay. So then we're going to go to 2B. I'm going to add this. This is our 2B compartment. Our dimensions, we're going to be 3.66 by 4.8768. Our height is going to be 2.9. Now our offset will be the 4.8768. Our Y offset is going to be 4.2696. And save geometry and view. So there's our new compartment there. So I go to my wall vents. I'm going to add. We have a window, and then we have a door into 2BC. So I'm going to do the window now, 2B to the outside. Solid 1, soffit at 2, width is going to be 1, face is going to be the rear. Now we're going to offset 1.5. That should be okay. It might be a little to one side, but it should be alright. So we're going to add compartment 2BC. So this compartment is, the width is 1.2168. The depth is 4.8768. The height is 2.9. Now the position in the X is offset. If we look back at our diagram, we can see it's offset this 8.5368. The Y, it's offset the 4.2696. So let's check that. Click Save, Geometry and View. So our window looks good, and here's our corridor. And I'll go ahead and do the doors. So we have a door into this corridor from 2B and 3B. So we'll add from 2B to, now we have to scroll down to BC. We're going to try the right face, see if that works. Same as it did last time. No errors, so we're going to save, click geometry and view. So once again, it put the door there on the right face of the larger corridor. So just pay attention. You know, you may have to play with your vent locations to get them in the right spot. So we're going to go from 2B to the outside. Outside. It's going to be the rear face. Save geometry and view. So this put, did I select 2B instead of 2BC? I did. So this, you know, when you get more comfortable with it, you don't have to check at each step, but I do try to check periodically to make sure things are lining up. So we're going to go to compartment 3B. The width is going to be the 3.66. Depth is going to be 4.8768. Height is going to be 2.9. The X position is 9.7536. The Y position is the 4.2696. So if you're going to do multiple stories, that's where you would change the Z. So we have some vents to add. We can add the window from 3B to the outside. It's going to be on the rear face. We can add the door from 3B to the corridor. Well, that reminds me, did I set the corridor? I don't think I did, so we'll check that after I finish this. So let's see where this puts it. So our door from 3B, it looks like it copied it over to here. Looks like it's layered on there. So let's try the right face. So there, now we have these, both of our doors are there. Oh, right, I was going to check I was like, there's something I was going to do. I was going to check the 2BC. I forgot we're going to set the flow characteristics as a corridor, and the 1BC, we're going to set those flow characteristics as a corridor as well. Alright, so we're going to add, we did 3B, now we're to 4B. So with the width is a little bit different, 4.8744. The depth is 3.66. The height is 2.9. The X position is going to be 13.4136. The Y position is 5.4864. So if we look back at our diagram, we can see this is where the 5.4864 comes from, and this is where that 13.4136 comes from. Okay, so then we're going to add this. The 4B only has one vent, and it goes from 4B to 4A. .2 width is 1. We're going to try the rear. No, we'll try the front face. See which corridor or which compartment it puts it in. Okay, so it put it again in this, a larger compartment. So we're going to try the rear face. So here we have all of our geometry for our compartment and all of our vents where we think they should be. So I'm going to stop this video here. The next video is going to talk about putting disappearing walls into the simulation. Okay, so I hope you found this useful and have a good day.